Okay, so we're given four terms of a geometric sequence, and those four terms are A, B, C, and D, and this is an increasing order. Let me get my eraser out. A, B, C, D. What else you told? You told the sum of those four terms is 220, and you told the difference between the third term and the first term is 44. All right, so what I would do is if you have a geometric sequence, I would, say the way it would go is A. The next one, the common ratio is R. We don't know what that is yet, but the next term B would be AR. The next term C would be AR squared. And the fourth term, which is D, would be AR cubed. Again, this is A, that's the B, that's the C, and that's the D. Well, let's write down what we know. We know if we add them together, that means A plus AR plus AR squared plus AR cubed would equal 220. I'm going to simplify that by factoring an A out. And when you do that, you're going to get 1 plus R squared plus R cubed equals 220. I'm going to factor the inside, that 1 plus R squared plus R cubed, by grouping. You're going to get this. You're going to get 1 plus R squared 1 plus R equals 220. Here you get A. Well, what would you get there? You'd factor out the 1 plus R, and you would get 1 plus R squared. That equals 220. Let me show you this is written. And this is an important first step, by the way. Again, A times the 1 plus R times 1 plus R squared equals 220. Let's look at the next thing they've given us, which is C minus A. What's C? C is A R squared minus A, which is just A, and they say it's equal to 44. All right, let's factor that. What do you get there? A, and you get R squared minus 1 equals 44. If you factor that, you get A, R plus 1, R minus 1 equals 44. Let me show you where that is. That's right here. All right. Now, by the way, looking at these things, it should be clear here that R is not 1. You would never get a product of 44 in that case, and the A can't be 0. I guess I should insert over here that the R can't be minus 1 either. I'll write that down later, by the way. And certainly the A can't be 0. So that's kind of clear. So now I'm going to kind of state that, and I'll update the notes to that. R can't be plus or minus 1, and the A cannot be 0. All right? So let's take a look. We have two equations and two unknowns. What I would recommend you do here is divide. And what do you mean by that? I would take A, 1 plus R squared equals 220. And I'll divide by this over here. So A, R minus 1, R plus 1, 44. What's nice about this, something happens, that's nice. What's happening over here? Well, 220 divided by 44 is 5. And the A's cancel. Again, A can't be 0. It would not satisfy those equations up there. And what else do I know? I know that 1 plus R is never equal to 0 because R can't be plus or minus 1. So this thing cancels off. All right? So what are you left off with? You're left off with this. 1 plus R squared over R minus 1. All right, this looks much easier to deal with. What do you get? 1 plus R squared is equal to 5R minus 5, quadratic in form now. You get R squared. Let's see, minus 5R plus 6 equals 0. I'd factor this. What do you get? R. Looks like 3 and 2. So I know my R's now. What can the R be? R could be 2. Or the R could be 3. All right, they want the sequence, though. They don't want the R, they want the sequence. So I'm going to go back and I want to figure out what the A is. And the way to do that, I want to point out, to do that, I'm going to select this equation here to do it. All right. So let's write that down. So I'm going to write down A is equal to 44 over r squared minus 1. Let's do that. And let's do it for the 2 first. So if I'm going to do this one over here, what would the A give me? A would be 44 over, well, 2 squared is 4, 4 minus 1 is 3. So I can write my sequence down now. And let's do that. And the first term, 44 thirds. Then I multiply by 2, I get 88 thirds. I multiply by 2, that's 176 thirds. I multiply that by 2, let's see, let me be careful about this. 200, 140, 340, and 12, 352. Okay, let's take a look at the case, see if we've got that. All right, I'm going to take my red pen out, and we'll see if I got that. 44 thirds. This is where R is 2, by the way. 88 thirds, 176 thirds, 352 thirds. All right, let's do R equals 3 now. And again, to do that, the formula again is 44. So let's write this down. A, that's going to be 44. And then what do you get? You get R squared, which is 9. 9 minus 1 is 8. Well, this one can be reduced by 4. You would get 11 halves. Let's write that one down. All right. What's that one going to look like? Let's write this over here. That's going to be 11 halves. We're multiplying by 3, so 33 halves. Multiply that by 3, 99 halves. Multiply that by 3, well, 270 and 27, 297 halves. All right. I do kind of recommend you probably should check these out, but we have 2 answers. I'm going to check with the key, though. 11 halves, 33 halves, 99 halves, and 297 halves. And again, this is when R is equal to 3. We got this over here, just like we did the other one. Again, I would recommend adding them together, making sure you get 220, yada, yada, yada. But it does work out nicely. It's not a bad problem. And you should be able to do a problem like that. Again, it does say it's optional, but you should be taking these options if you can, if you have the time for it. Thank you.